In this video, I want to talk about the variance of a random variable. Variance can be denoted by a sigma, the Greek letter sigma, squared, or by this VAR of x, where x is our random variable. And there are two different ways we can define this. The first way, the variance is equal to the expected value of x minus mu squared. This way of defining it kind of tells us what we're doing. This x minus mu looks at the distance from the mean. We then square it to get rid of positives and negatives and make sure everything is at the same sign. And then we take the expected value of that. So we're finding the average distance from the mean. The second way to define the variance, the expected value of x squared minus the expected value of x, all squared. And this is the more practical way. Whenever we're computing it, this right here is the method we prefer. Let's start with the discrete random variable with probability mass function p of x. We can then define variance as the sum of all of the values x in our sample space S of x minus mu squared times p of x. Alternatively, using the other definition, the more practical definition, it's the summation of all x in our sample space S of x squared p of x minus mu squared. So this is the method we'll use the most often. Next, let's suppose we have a continuous variable with probability density function f of x. The first way to compute the variance, the integral from negative infinity to infinity of x minus mu squared f of x. And then the more practical definition, the integral from negative infinity to infinity of x squared f of x dx minus mu squared. So this will be the method we actually use when we compute this. Before I do an example, I also want to define standard deviation. Standard deviation is denoted by sigma, and it's the square root of variance. In other words, sigma is the square root of sigma squared. First, we're going to select a product from the production line and let x take the value 1 or 0 as the product is defective or not. We're going to let p be the probability that the selected item is defective, and we want to find the variance of x in terms of p. Since this is discrete, we're going to do the sum of all x and s of x squared p of x minus mu squared. And in a previous video, I actually found mu of this distribution to be p. So the first possibility is 1, the fact that it's defective. This has a probability of p. We then want to add in the next option, 0 squared, times its probability, which is 1 minus p. So this part is the summation of x squared p of x. And then we're going to subtract the mean squared. So this says p minus p squared, or p times 1 minus p. So this will be my variance in this particular case. Next, I want to roll a die and let capital X be the outcomes, find the variance. So let's start with actually building our PMF. If we roll a die, there are 6 possibilities, each of which have a probability of 1 over 6. We could roll a 1, a 2, a 3, a 4, a 5, or a 6, and each of those have probability 1 over 6. In our formula for calculating the variance, we need to look at x squared p of x and sum those up. So let's insert a new column called x squared p of x. 1 squared is 1 times 1 over 6. 2 squared is 4 times 1 over 6 is 4 over 6. 3 squared is 9 times 1 over 6. We then have 16 over 6, 25 over 6, and 36 over 6. And then we need to add all of these values up. When we do, we get 91 over 6. From there, we need to subtract the mean squared. So we need to find the mean of this. in order to find the mean, we're going to have a new column or a new row that's just x p of x. So we have 1 times 1 over 6, 2 times 1 over 6, 3 times 1 over 6, 4 times 1 over 6, 5 times 1 over 6, and 6 times 1 over 6. And then we need to add those up. When we do, we get 7 over 2. So we're going to subtract the mean squared. So 91 over 6 minus 49 over 4. And when we do that, we get 2.92 roughly. So this would be the variance of this particular case. Next, let's let x be the uniform distribution from 0 to 1. Since this is continuous, I need to look at the integral from minus infinity to infinity of x squared f of x dx minus mu squared. And in a previous video, I showed that the mean of this distribution is 0.5. In addition, f of x is defined to be 1 between 0 and 1, and 0 otherwise. So when I do this integral, the integral from negative infinity to 0 is 0. The integral from 1 to infinity is 0. So we really only need to consider the integral from 0 to 1 of x squared times f of x, which is just 1. Once we integrate that, we need to subtract the mean squared. The integral of x squared would be 1/3 x cubed, taken between 0 and 1. And then we're going to subtract 0.25. So we end up with 1/3 minus 0.25, or 1/3 minus 1/4, which turns out to be 1 over 12. Finally, let's let x have the PDF f of x equal to 0.1 e to the negative 0.1x for x greater than 0 and 0 otherwise. This time I want to find the variance and the standard deviation. And in a previous video, I showed that the mean of this distribution was 10. For this one, I would need to look at the integral from 0 to infinity, since everything smaller than 0 is just 0, of x squared times the function, 0.1 e to the negative 0.1x dx. And this will actually require integration by parts twice. And if you work that out, you get 200. So we have that value minus the mean squared. When we work that out, we get 100. So that would be my variance. The standard deviation is then the square root of that. So the standard deviation here would be 10.